Well, hello everyone. Welcome to We Need Our Space, a special show for you today because we have Stephen van Vuuren here. We're going to do an interview with him. He is the director of the film In Saturn's Rings, and that will be starting at our planetarium next week. Now, this is a special type of film because when you hear about a movie that is based entirely on Saturn, you'll probably think that it deals heavily with CGI and animation. But people should know that everything they will see in this film is going to be real. Everything is real. It's done so in such a painstaking detail that it is quite literally the best way and the closest that people will come to actually experiencing visiting Saturn up close. So to get a sense of this, let's kind of take a second here to kind of watch the trailer for the film to kind of get a sense of what we're talking about. And from the trailer, we will get right into the interview. So enjoy.
This is real. Our voyage to explore made real. We dream of exploration, of crossing the gulf of space and time, and discovering wonders beyond our imagination.
All right. So, welcome to We Need Our Space. It is good to finally talk to you. I was saying before on the last week's show how In Saturn's Rings was this show that I was hearing about when I first became the producer back in, I think it was 2014. As the last guy was leaving out, he was like, you need to keep an eye out for this show, In Saturn's Rings. It's going to be a great show. Kind of described it to me a little bit, and I got super excited about it. And so I'm very excited to finally debut it in our planetarium. I've seen it. It looks phenomenal. So this is Stephen van Vuuren. Did I get that right?
He did.
All right. So welcome. So to begin with, In Saturn's Rings is it's a groundbreaking show in the sense that there hasn't been a film quite like it, and unlikely that there will be anything like it since. And by that I mean that it would be a Herculean effort to do something like this again. But people have heard of animation. They've heard of stop action animation. But this film is a multiplane photo animation. And so what are some examples of multiplane photo animation? And kind of give us an example of films that have used this technique, and so people can kind of wrap their head around what can be expected and what they'll be seeing.
Sure. Well, this all comes from necessity is the mother of invention, because when I first had the idea to do this film, I'd never heard of multiplane photo animation. I knew about animation, the same thing that you just said. I knew about stop motion. I knew about animation techniques. but this was something I did not know about at all. And I just wanted to make a film that was going to use real photographs as the images and not CGI. That's all I knew. And when I was digging around, I was led to two things. The first thing was Walt Disney. And Walt Disney created the multiplane camera. In fact, there's a great clip on YouTube that is in Walt Disney style that he produced that is like 6 or 7 minutes long, that shows the multiplane camera. That's very entertaining and be great for you guys to share on social media. When I do talks on the film, I'll often show that clip because it just explains the whole idea of why you break animation up into separate planes. A foreground that's close, and a midground where my head is, and then a background there. And by, when your animation is just in a single plane, you can't create any sense of depth when you move the camera. So if the camera is moving like this, the background, my head changes in size much more dramatically than the monitor there in the background. And that's the whole idea of multiplane animation that Disney, it was like, well, if he drew Bambi, in the midground, and then had trees up here in the foreground that were on a separate piece of transparent animation cell, and then the background, the woods in the distance or the moon or the sky back there on yet a separate piece, and these were stacked. So there'd be a camera pointing straight down at these layered glass where they put the animation cells one frame at a time, speaking of tedious. And this camera took up like, 2-3 story room, because he had up to 11 planes that he would use in his films. And that's why Disney animation, Bambi and Snow White and Sleeping Beauty, if you go back and watch them, you can see that multiplane animation and what a difference it made over just plain, 2D animation, with creating that sense of depth, especially when the camera is moving. I was like, well, that's interesting. Has anyone done this with photographs? And that led me to a film called The Kid Stays in This Picture. That was about the famous Hollywood producer, Robert Evans. And he did not want to appear on camera. He's like, no one's going to see me or my face, but you can use photographs of me. So the documentary, it just has a few minutes of it, but it took photographs, and to make them more interesting, it split the photograph into a foreground, background, and midground to create a sense of depth. And when I saw that, I was like, very naively, was like, sure, we can do this and make a giant screen planetarium movie using that technique. And I was too ignorant to realize what a nightmare that I had created. The biggest reason is when you take a single photograph and if I cut out my head behind here, it's not going to see this because it's a photograph. There's just going to be a hole. So what they would do when this technique is used, and it's used mostly in music videos and commercials, no one's ever made a long format film with photo animation before because it's a stupid thing to do, because it's so much work. But what they would do is they would just Photoshop in what was missing there. But because we were doing a science educational film and we were dealing with very large objects, we didn't want to Photoshop because we didn't actually know what was there. So what we did is we would find multiple photographs taken, like when Cassini's going around Saturn, it's taking still pictures. My head is Saturn. It's taking picture. And so all those little pieces of the background, if you look at that blue box, we could figure out what was behind there and find the data. And so we could put in the missing data as we put it together. So you can start to see how crazy this got very quickly.
Absolutely.
And that is what the film was, is we were creating multiple photographic layers by figuring out what would be in those different layers when we had a complete reference photograph to use. And it always was a series of photographs. And once we had that, we could move the camera And with those various angles that we had, we could double check and make sure that we were getting everything as right as we could. Is it exactly what you would see? No, but it's far more accurate than what you can recreate with CGI, because CGI of space objects, it falls down because when you're doing really accurate CGI, you've got to model the physical properties, both internal and external, of the object that you're doing. And they still don't know much about Saturn, and certainly galaxies and moons, and there's still arguments about the internal composition and the chemical composition and how it reflects light. So it's really, you end up doing sort of photographic mimicry in CGI, which ends up looking very fake. So that's why this, we feel, was worth the effort, though it ended up being 14 years, and we are still rendering the native full dome. Because some of our shots got very complicated. And believe it or not, this is an extremely short, abbreviated summary of the process used in the film. Yeah. But right now for the native full dome, we're rendering the shot where we show 5 million galaxies. And because we're not using CGI to show 5 million galaxies, we had to find 5 million photographs of individual galaxies that we could position as individual planes. So that's 5 million planes. So Disney did up to 11. We did 5 million. And I actually, just as an exercise, I was like, what if we did this the way Disney did it? So I looked up glass printing, what's the highest resolution you can print a photograph on glass, and measured out everything with the position. And I figured out we would need glass plates that some of them would be very tiny, but the big background plates would be 1 kilometer square. And the camera height would need to be anywhere, we'd need to go from 1 inch to 5 kilometers high to do the shot physically without computers. So that gives you an idea of the scope of the amount of data that we're dealing in. This 5 million galaxy shot, people talk about megapixels, and then people try to impress you with gigapixels. Well, we had about 8.5 terapixels of data in that shot, which is why it's taking so long to render out those frames.
Now, why did you just decide on 5 million galaxies? Why not just 4?
That's a great question. So, and I really encourage people, again, because it seems like I'm going into a lot of detail in here, but I'm actually doing the reverse. I'm terribly summarizing. There's a long article on our website about how we did the 5 million galaxy shot. But in short, the film is the way it is because we could not write the film the way you normally do a film. Like you write a script and then you film the script. We had to go look and see what data was there, like what photographic data is available, how high resolution it is, what kind of image can we make, and then we had to write a film using that. So in a lot of respects, In Saturn's Rings is a found footage film, if you know that phrase. Mm-hmm. Where you just find, stock footage lying around and you make a film with what you have. And that's what we did. We looked at, well, if we're flying through the galaxy, what's the best imagery? And that imagery is in the Sloan Digital Sky Survey. Mm-hmm. And we basically took pretty much all they had, which was about 33% of the sky. And then we put that data into a visualization program called Space Engine, which is a free open source program. And we looked at it and thought about the angles and the size of the screens and how much data was in SDS, and SDS told us there are 5 million galaxies here. And so that number was chosen for us. We never chose it, it chose us. And that's really the best way to describe the film. All the images that you see are images that showed us, like flying through Saturn. Cassini determined what we could show and what we couldn't show. We had lots of ideas for cool things, but there wasn't the photographic data to make the multiplane layers to make the shots work. So we just had to go with what we had. And much of the film, because it took so long to put it together, except for a few sections of the Saturn fly-throughs, everything is the first take. We had one shot to create the shots. There was no refining and revising and tweaking like you would do a CGI to get it just perfect. It took years to put stuff together, and when we were at the end of that process, what we had was what we were going to have. Otherwise, it would have taken 30 years.
Right. Oh, wow. So now I see that you've done some short films before in Saturn's Rings. Now, is your background in science or primarily in film and editing? And by that extension, how did you arrive at working at this particular project in Saturn's Rings?
So that's a great question. I am definitely not a scientist. And that's why we included a lot of people in this who were a lot smarter at science than I was, including, actual astrophysicists and mathematicians to figure a lot of this stuff out. So my background is as a filmmaker. I went to film school, dropped out of film school. The important part of that is I spent 10 years in the computer field and learned how to build computers and networks and servers from scratch, which is the only reason that this film got made. Because at one point I had in the basement over that way in our laundry room, 33 rendering workstations. There are still 6 stations rendering in there right now, the full dome, but it requires very high-end GPUs, so I had to get rid of the others. And 2/3 of a petabyte of storage. So that computer background became very useful. But in 2000, I got back into independent filmmaking. Typical independent filmmaker, made short films, and I've kept making short films as in Saturn's Rings has gone along. And I've co-produced and worked on a couple of feature films. I do a lot of post-production work for other filmmakers, like making DCPs, sound mix and editing, and have worked on a lot of feature films. That way, I think about maybe 150 over the years, doing various post tasks.
Okay. Well, before tackling in Saturn's Rings, you must have experimented a little bit to get a sort of proof of concept, right? So if you did do this, did you kind of become familiar with the photo animation, and did any of this become viewable publicly, your proof of concepts?
Sure. Yeah. I mean, I think it was more than proof of concepts. It was like, can this be done?
Right.
Because that was an open question. And from 2004, it took me from 2004 through 2010 to get the first 1.5 minutes of footage from the film. And the first 3 years was kind of like a little part-time, but from 2007 to 2011, it was a full-time effort to do proof of concept. Some of it was terribly, painfully bad, because what proved to be a problem was the rings of Saturn. They did not respond to the photo animation techniques that had been developed at that point. So I had to develop something new that had never been done before. And that was my primary contribution, was refining multiplane photo animation, which is funny because I went from not ever having heard the word to kind of developing these new techniques that had not been done before, just because I would have no film if I could not multiplane the rings of Saturn. And so that was the effort. And in 2010, I uploaded the first 1.5 minutes of footage with a multiplane fly through of Saturn. And that really changed the fortune of the film. So it took about a year for it to go viral. It sat there. It's a good lesson in patience. I'd given up. I decided nobody thinks this is cool. It's had 227 views after a year. But then a website got a hold of it, and then we were up to 1.5 million views type situation.
Yeah, I think it was Sam Raimi that said, whenever you're working on something, if you think it's cool, then the odds are somebody else out there will think it's cool as well. It just does take a little bit of patience sometimes for the right person to get their hands on it. Well, at what point did you realize that the planetarium was maybe an ideal place to show this type of film? And what kind of complications did that create for you? Because full dome and flat screen are two very different things when it comes to making these films. Yes.
So fortunately, I had I didn't know anything about planetarium filmmaking, but planetarium had been in my brain as a venue, but I was completely ignorant of both giant screen and planetarium filmmaking when I got started. But I had a chance meeting with James Hyder, who writes a trade publication called Elf Examiner in Las Vegas. And by purely chance, we just happened to be at the same table eating at a non-film, non-related to Cassini thing, and was like, what do you do? Oh, I'm doing this. Oh, I'm doing this. And he was the one who said, well, this needs to be an IMAX film. And I said, well, I was just going to do something in a planetarium. And he said, well, do you know anything about planetarium films? I said, no. And he explained Full Dome to me, and I was like, oh. But that was like 2006. So I realized I needed to learn. So I was always planning on what we've done here, which was to make sure that the film would end up natively in giant screen and Full Dome. And I knew those were very different, but the film ended up being designed and has been designed as an 8K square image from the very get-go. So when I was evaluating whether we could use data or not, I was always thinking about it has to be able to work in Full Dome. And that was also the choice to create the film in Adobe After Effects, because that way the film could live in both places and the work would not be from scratch. If we had used two different applications, I mean, typically Full Dome is using more CGI type stuff, which would have been hard since we had no CGI, we only had photographs. But nonetheless, we would have had to make the film twice. But this way, it's still a lot of extra work, but it's more like 50% of the work again, rather than twice the work. Because what we've been doing since the giant screen was released in 2018 is going back through the film and recomposing and re-rendering shots, all native Full Dome, and of course, changing the frame rate and doing the things that you do for native Full Dome content, and using VR headsets and a local dome here to look at how the shots are turning out to make sure that we get the native Full Dome right. And I always knew, always had an intuition that Full Dome was ultimately going to be the best place for this film to be. But I really had this validated when I'd gotten just 3 or 4 minutes of Full Dome footage together. And our local native Full Dome setup has a 2K Konica Minolta projector, very old projector. It is not very good, bless their hearts. It's got terrible color reproduction, terrible contrast. And I took some people who had seen the film in 4K giant screen and showed them a few shots in native Full Dome. And it's only a 45-seater. It's tiny by Full Dome standards. And I was sure they were going to be underwhelmed. They were blown away. They were so excited. This is way cooler than giant screen. And there's just something magical about the dome. And even though those shots weren't perfect and needed work, just from an audience perspective, there's just something about the Full Dome and that I think works. And I think Full Domes have been hungry for images that are not CGI. And I'm really excited about what this native Full Dome, because even the transformed version, I just think is better in the Full Dome than it is on giant screen. And the native Full Dome, especially in 4K and 8K venues, it's going to be something special.
Yeah, that's something that, you hit upon something that was one of the big selling factors for me, is that when it comes to Full Dome stuff, there's not a lot of live action stuff out there. There's just a lot of CGI, there's a lot of animation, because it's so difficult to film in Full Dome, you know. When I do stuff for our planetariums, I do time-lapse stuff with a fisheye lens, but when it comes to shooting live action stuff, that's a totally different thing altogether. So seeing this and seeing how everything was real, and seeing how it looked in Full Dome and how immersive it is with your horizon being on all sides of you, definitely the perfect environment, I think. But I do want to go back to something real quick here. because this is the largest multiplane animation film in history. And I want to kind of compare this to something that maybe Disney has produced, possibly, to kind of give people an idea of what this is. Is there an example of like a Disney film out there that used multiplane, whether it be Mary Poppins or something to that effect?
Well, that's the real interesting thing. As far as multiplane, Disney only used it in their pure animation.
Okay.
The Mary Poppins and those, they did a sodium vapor lamp thing to create that composite. Very cool, very innovative type thing, but it was a different process, different workflow. This is on the only way I can think to explain it is the most complicated multiplane I know about was the kid stays in this picture. And a couple of times I've seen some multiplanes done in some Nike ads, but they're doing 5 to 10 layers at 2K resolution. Whereas we are just exponentially, the simplest shots in Saturn's Rings would start at the most complicated shots that anybody else has ever done.
I was watching something on that Mary Poppins and the type of camera and the crystals they used. You might have seen the same video I saw on how they did the photo compositing for those Mary Poppins scenes, and it's pretty crazy.
Well, and the thing is about the reason that we did it is the reason nobody's ever done it before, like I said, it's stupid, because you would only do it to a place where you couldn't take a camera. Because if you can take a camera there, camera is the ultimate multiplane photographic animation tool, because it just does it just captures it as it sees it. You're basically trying to mimic what happens with a real camera. And so you would only do it where you had high resolution photographs, but couldn't get a motion picture camera. So the list of subject matters for that is very thin. Like the bottom of the ocean, we can't get easily motion picture cameras down, but we don't have high resolution data. It's space missions and astronomy that made our film possible. And we're in enormous debt to all the missions that we use this high resolution data, from the Solar Dynamics Observatory to the Apollo missions to SES to amateur astrophotographers, all the different people that contributed images, and of course, especially to the Cassini space mission and the imaging team behind Cassini, because they did so much to get as much good imagery and understood how important that was. That it's not just the scientific data, but gathering a lot of images provides a rich well that allows us to create art and beauty, which in turn inspires people to learn more about science and often to become scientists themselves. That's a legacy of Carl Sagan and others like him. And that is a powerful feedback mission, and the only reason that it was possible. So that's why there just aren't comparable films, is there's not really comparable situations to what we did. So I'm not sure if anybody will ever attempt another film like this unless they decide to do it about the same subject matter, which is space. I'm pretty confident that no motion picture cameras will ever get to other galaxies. So if you want to do galaxies right, this is the way to do it.
You mentioned something just a second ago, and kind of made me think of something here. How does this, not to kind of keep harping on this, but how does this compare to what's called the Ken Burns effect?
Yes.
Because when you're describing this, to me, it sounds like the Ken Burns effect, but they're two different things. So how do the two kind of compare and contrast?
So the Ken Burns is a kind of like the simple level of multiplane photo animation. So the kid stays in the picture basically built on the Ken Burns effect. And the Ken Burns effect is splitting a photograph into 2 layers, pretty much, foreground and background, and then scaling and zooming them independently to mimic a camera move.
Okay.
And then what happened with the kid stays in the picture, they started experimenting with a couple of more layers, and getting a little more precise about that. The Ken Burns, you're really just doing it to make a photograph look interesting.
Okay.
But we went several steps further. We added math to it, which is, we just didn't want to do something cool. We wanted to make sure when we split things into multiplane that we were getting everything the right size and scale. So the camera distance and this object, when we're splitting things into backgrounds, like everything's the right size and in the right place. And of course, we couldn't always answer those questions perfectly. And sometimes the data wouldn't allow us to do it the right way because we couldn't find high enough resolution data to get every shot. Like your eagle eye audience people will notice that we get the wrong side of the moon in one of our shots because the dark side of the moon, there wasn't the high resolution imagery that would work at that point at all. So if you're really eagle-eyed and freeze-framed, you can kind of deal with that. But nonetheless, we were trying to get it right. And so adding math is our secret sauce with our multiplane. And then something else happens when you do that, even though it's mathematical. For me, it gets more beautiful because it gets more natural. That's why the fly-throughs in the film feel that way, is because they have fortunately, Adobe After Effects allowed us to put ridiculous pixel values in there so we could mimic the actual distances that you get in space, because it would take pentillions for a pixel position. So when you're doing an XY, how many pixels away do you want this to be? 5 trillion pixels away. And Adobe After Effects had no problem with that math, which was something that would have been very problematic if it wouldn't have allowed that.
Yeah, that's the program I use to put together our own planetarium shows in-house, in case people are out there wondering. But now, as a musician yourself, I'm sure you've come to a point where you start working on a project and you start getting to a point where many musical projects usually get into an area where you are covering new ground. You're doing something that you haven't quite done before. So was this the case in Saturn's Rings, where you started to work on a section and you've learned so much in the process of creating this film that you kind of wanted to go back and redo old scenes, kind of scrap what you've done before and apply what you've learned over that time? So did you ever go back and want to redo scenes from what you've learned?
You're speaking at the agony, because normally when I do films, I edit a lot. I mean, I that's probably the job I feel most comfortable in, as an editor, and often I work for others as an editor. And then I'm constantly going back and reshaping and reworking and redoing scenes, and sometimes adding a reshoot or redoing a composite. In Saturn's Rings is painful for me to watch. Like I said, we only had one take or one shot at all of it. And certainly if we were going to do it again, there was a lot of things we would do completely different. I mean, especially since we were inventing almost always new techniques for doing things to get them done. So I would say almost every shot in the film, except for maybe one. There's one Saturn fly-through shot that I think is absolutely perfect, and it's my favorite shot in the film in a giant screen. I haven't decided on my favorite native full dome version yet, but everything else I could tell you how to improve, but it couldn't be done. The only things that we were able to make some changes and revisions were for some titles and text based on some early feedback, and improving the color correction in some spots and things like that. So that was a very difficult part of the process for the film for me, was not being able to do what you just said, because absolutely we would, but that's for someone else who's got 15 or 20 years to spare to tackle.
Sometimes that's for the best. Sometimes you work on a scene or you work on a piece of music and you want to go back and improve upon it, but you can't really quite get that magic that was there. I don't know if it's part of being married to what you're used to, or trying to, I don't know, I just find that kind of trying to recreate something that has been done before can't really quite capture the moment. So sometimes that's for the best, I think.
That's true. And the one thing is, I will add an asterisk to that, because we are recomposing and re-rendering for the native full dome, it's a bit of a mixed bag. Some shots don't quite work as well in native full dome, not because of anything wrong with the dome, but because we don't have quite the data we need to compensate for the fact that these are flat 2D photographs and the dome curvature is so strong. That's where CGI has an advantage, but so we kind of have to simplify those shots a little bit for native full dome. But on the flip side, we had some technical problems with the image processing pipeline that we were able to correct, and specifically the 5 million galaxy shots, that has been significantly improved for the native full dome, and especially the 4K and 8K native full dome versions. Those are going to be just, it's a unique experience. It's something that you cannot ever see in a real photograph for real, because there's not a field wide enough and detailed enough on a telescope to capture that yet. So our recreation of that is a one-of-a-kind visual experience, and in full dome, it looks substantially better than the flat screen. So we are able to do a little tweaking in the full dome, and the full dome in general will be our revision, but we can't really redo things from scratch. In other words, getting new data and coming up with new shots, because it would just take way too long. Yeah. We have to use what we had.
We have a 4K dome where we were at. I had seen the difference of how a film looks in 4K and 8K. I went to the Fisk Planetarium in Colorado, and I saw a film there that was in 8K that I had just seen in Denver that was in 4K. So seeing those two back to back in those two formats, I could definitely see an improvement and the difference. And since we had the 4K large screen version, but we will transition to the full dome version whenever that becomes available, and I will definitely travel to an 8K location if they get the film in full dome, because I would definitely love to see it in 8K. And that being said, for my last question for you here, I have heard, well, I've read in an interview that you have tried to future-proof this show, and by that it means shooting this or making this in such a way that when you show it far ahead into the future, it will still look amazing, right? Like we can still watch Jurassic Park now, and Jurassic Park still looks incredible. You know, they did a great attempt at future-proofing that show. So with that, what did you do to try to future-proof in Saturn's Rings to continue it looking as good as it does into the future?
That's a great question. And actually, that's the first time I've ever gotten that question, and all the times I've talked about the film. And I appreciate you asking that, because I certainly lost years of my life due to that, because I had one of the early meetings I had when I was getting started, before I had, this would have been about 2008, is I met Andrew Oren, who's the vice president at Photochem, and he works on a lot doing the post-production and technical aspects of film processing and post-production and digital for Photochem, which is now the leading laboratory. So Christopher Nolan's films, Disney's films, everybody's is going through Photochem, and they do restoration. So he's as good a person on the planet to talk to. And I wanted to find out, and fortunately he became a fan of the film and let me test things, do film outs. And I saw what the film looked like on 1570 film, which is the highest quality film that you can still get today. And in doing that, I realized I needed to do two things to make sure that the film would last as long as anything that's being made, and maybe even a little bit longer than stuff that's being made. And that was to master, not just capture, because you can buy an 8K camera today, but are you going to edit in 8K? That's the bigger question, because Hollywood, there's a lot of famous films like Avatar was only mastered in 2K, and I've watched it. I tried to watch Avatar on my 4K projector here that I have right over there is the screen for it. And I had this projector tweaked for looking at giant screen and full dome material, so I can sit real close, and it's got a real nice pixel structure. Avatar was not watchable here. It was not future-proofed. The effects looked poor. The pixelation was obvious. It's just, I was stunned how unfuture-proofed Avatar was. And I think when people have 8K televisions and start to watch Avatar, they'll go. And I have it doesn't up-res, but still. But that was a big thing, was like, I need to master at 8K, and I need to master in 16-bit color. In testing with film and whatever, if you're not mastering at least 16-bit color, it's just not going to hold up going out to all the different formats of the present and the future. Yep. So that cost us a lot in processing time and storage space to do that, but it was done. And that's the reason we're able to have an 8K full dome today. That decision to do 8K full dome was made in 2009. It's like that's where we're aiming to. And I can't tell you the number of people that tried to talk me out of doing that. But today, even though it probably added 5 years to the 14 years of making the film, I would do that over again every time, because I feel such an obligation to all the volunteers and donors that gave us so much of their time and their money and their support, and also a responsibility that this will probably be the one film that gathers the most of the scientific imagery. Much of the images in the film have never been seen by any human eye, because scientists don't get around to going through all the photographs, but we have all the photographs from Cassini that it ever took in the film. We have 5 million SDS images in the film, and hundreds of thousands of other images. And I felt that they should be captured and preserved for future generations. So,
well, it was a wise decision, because there are certainly planetariums that will buy much older shows and run those shows and for years and years to come. So this is definitely a good decision to make, because you can definitely watch this show and have it will still be relevant, decades and into the future. So it's a good choice there. And with that, I guess we're going to be done with the interview here. I think Saturn's Rings is a phenomenal show. I can't wait to start showing it to the public. I think it will blow their minds. So thank you for talking with me today, and I will let you know how it goes.
Well, please do. Again, thank you so much for you guys showing the film and sharing it. We're very honored and excited that it's going to be down there, and hope everybody enjoys it. And thanks for the great questions.
Thank you for your time. Enjoy the rest of your day.